Hello there. Right now we're going to go over the Unit 4 test. Okay, so let's mark this up here. And we got this first question. So here it's saying this function has a blank at x. So the answer we want to put here is the words minimum or maximum. So think of this as a roller coaster. Do you hit your lowest point on the roller coaster or your highest point there? And here we're going to hit our lowest point. So we're going to reach a minimum at, hang on. So I think we would write the word minimum here. We reach a minimum of, and here we're talking about how high you are. And so here this is going to be -4 at x equals -5. So this right here, that's your y value. So you reach your lowest y value. The minimum height of your roller coaster is -4. That's how low your roller coaster goes. And your roller coaster gets to -4 at milepost -5. Okay, that's what that means. Okay, the function is increasing on the interval. So increasing, it's increasing on this bit along there. So it's increasing, and now here, whenever we do these intervals, we're always just talking about the x values. So only looking at the x values, this is from -5 to infinity. The function is decreasing on what intervals? I want you to think of this in your mind. You can pause if you need to. And yeah, it's going to be -infinity to -5. Now notice I'm using this rounded bracket here. Rounded bracket here. Okay, why am I using a rounded bracket? Because right at -5, I'm neither increasing or decreasing. So this is saying from -infinity to -4.9999999, we're decreasing, and then from -5.000001 to infinity, we are increasing. Okay, domain. The domain of the function, these are only the x values, is from -infinity to infinity. That's where you are, that's the domain. Those are the x values. This function goes all the way to -infinity, and it goes to +infinity. Okay, now range, remember, is talking about x and y value. Sorry, range is just the y values, how far up and how far down. So here we're going to first of all talk about the lowest and then the highest. So the lowest this thing goes is down to -4. Again, only talking about the y values. The highest this thing gets, well, there's no limit to how high this goes, so I'm going to write infinity. All right, now for the brackets. Infinity always takes a rounded bracket. What about that -4? Well, we know for a fact it will reach -4, and so we're going to do a square bracket right there. Okay, so again, domain is how far to the left, comma, how far to the right. Range is how far down, comma, how far up. Okay, and then, yep, that's it for that guy. So this next one, question 2. Write a possible equation for the graph. So let's use this formula. Y equals a absolute value x minus h plus k. Now a stands for the slope. What is the slope of this guy? I'm arbitrarily going to pick a point there, and I'm going to pick a point there. Now between those 2 points, I went up 1, and I went over 1. So 1 over 1, my slope is 1. And this graph opens like this shape, and so the a is positive. So this is +1, so I can write this as +1. Now I'm going to do x minus, here we're talking about the vertex. That point right there, that point is the point -1, comma 1. So here we're going to be x minus -1 plus 1. So I can rewrite this now as x plus 1 plus 1. Okay, that is my absolute value function. Again, this thing, the sign flips. This one comes straight down. That's my vertex. My vertex is -1, comma 1. There's an invisible 1 there. That 1 means my slope is 1. Okay, next guy. Complete the description of this function. So this first bit, let's describe that line. So this line here, we're going to first find out the slope. So I'm going to just pick that point and that point. Now, between those 2 points, how much do I rise? Right, I rise 2, and I move forward 1, so up 2 over 1. So my slope is 2. Now, using my point slope form goes like this. Mx minus h, x minus h. So this is the equation of a line that goes through the point h, comma, k. So this is going to be 2x minus, now I need a point. Now I'm going to choose this point right here. This point is going to be -6 comma -4. So x minus -6 minus 4. So 2x plus 6 minus 4. So that goes there. 2x minus 6 plus 4. And we can leave it in that form. We don't have to simplify. Now, could I have used this point right there? Yep, I could. That point is going to be -2 comma 4. So another way of writing this could be 2x plus 2 plus 4. Now, I'm not going to do this, but if you wanted to, you could simplify both of these, and they will turn out to be the exact same equation. Okay, now this next one, I have this line. Let me change colors here. I've got this line from there to there. Now this line, what stays constant as I move my cursor from left to right? You're right, the y value stays the same, so this is just 3. This is the line y equals 3. Okay, so that one's easy. This next one, we've got that one right there. Okay, first of all, let's actually do a different color. Let's do this one in blue. So first of all, on this one, the slope. The slope is negative because it's going downhill. And, this one's a little bit hard to see. Let me zoom in a bit here. And I've got that point, and I've got this point. See that point right there? Between those 2 points, I'm going down 1 over 2. So my slope here is -1/2. And now we're going to do x minus, and what are the coordinates of that point? The coordinates of that point are 3, comma 2. So x minus 3 plus 2. So we'll put that in there. -1/2 x minus 3 plus 2. Okay, let's go through that one more time. So how did I get this? I'm using this form. And my slope is -1/2. How do I know it's -1/2? I chose this one right here because I couldn't really quite figure out what the y value was on that line. It looked like 1/2, I just wasn't sure, so I chose that point. So between this point right here and this point right there, I'm going down 1 over 2. So the slope is -1/2. And then I'm just going to plug in those points right there. Okay. All right, so that's that one. Let's go and do this guy. Okay, sketch a graph of this thing. So first of all, write this out again. X plus 1 minus 2. First of all, is it a V or is it a, I don't know, like an A shape? Because this is a +1, there's an invisible +1 there, I know it's that. Okay, and now my slope is 1. And my vertex, my other bit of information, my vertex is flip that sign, -1. This one doesn't flip, just go straight in. Okay, so let me start graphing this. -1, -2. Let's make a dot. -1, -2. I got my dot there. And it opens up like a V, so I want something like that. And my slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. And this one, same kind of thing. This slope is technically -1, but same kind of deal. Okay, so that's it. Now it says the zeros of the function. The zeros of the function are going to be -3 comma 1. The zeros here are just talking about the values of x that if you plug them into an equation, produce an output of 0. So zeros are x values that give you a 0 output. Okay, so -3, 1. Now the x-intercepts are these guys, but just in the proper, coordinate pair. So -3, comma 0, 1, comma 0. That's the distinction between those two things, the zeros and the x-intercepts. They're related, they're just slightly different. X-intercepts are the coordinate pairs. Zeros are just the x values. And the y-intercept is -1, comma, other way around. It is when x is 0, y is -1. Okay. This guy. Use a table to find those values. F of 3. So f of 3 is 6. If f of x equals 1, then x equals what? So f of blank equals 1. Looking through this, there's the 1 and 6. If I feed my equation the number 6, it will produce a 1. Okay, this next one. Inverse function 6 is what? So this says I'm going from this direction. So inverse function 6. So here, if I feed the equation so that's 6, and now I'm going in this direction. And so that's a 3. So another way of writing this is this. If f of 3 is 6, inverse function 6 is equal to 3. So that's two different sides of the same coin. Okay, this next one kind of bends your mind a little bit. If the inverse function of x is 6, then x is what? So here I'm going this direction. So inverse function of what is going to produce 6? So I'm looking now for 6 in this column, and I see it right there. And if I feed the inverse function a 1, then I'll get a 6 out of it. Okay? Let's do this one. Same kind of deal here. F of 8 is 9. If f of x is 7, so it's saying f of what equals 7. So here I'm looking in this column, and I get that guy. So f of 6 is 7. Okay, now f -1, 9. So here we're going to go in this direction. And so that's going to be 8. Inverse function of 9 is 8. And this next one, inverse function of what is 6? So I'm looking now at that one. And if I feed my inverse function a 7, then it'll produce 6. Okay, so this direction, this is f -1x. Okay, so if I feed my inverse function the number 7, then it'll produce an output of 6. Okay, this guy. Intervals of increase, intervals of decrease. So increasing, let me just trace this. Increasing on that bit. And it looks like from -3 to, like 0.5. So -3, 0.5. Zoom in a bit so you can see that better. So again, when we're talking about these intervals of increase and decrease, we're just talking about the x values. So when x is from -3 all the way up to 1/2, then we are increasing. Now remember, always use rounded brackets for intervals of increase, decrease. Okay, intervals of decrease, that's decreasing, that's decreasing. So from -infinity, as far as we can tell, all the way up to 3, you're decreasing. And from, that looks like 0.5, all the way to infinity, we're decreasing. The way you connect those is with a big letter U. I think in this math program, you just type in a big capital U, and then it's happy with that. Okay, so those are the two intervals of decrease, from -infinity to when x is -3, and from when x is 1/2 all the way to infinity. Okay, this guy. Let's talk about these different bits here. So here along this thing, what stays consistent is my y value. My y value always stays -3. That's easy. Now, this one right here, we've got this curve. Now, how do we find what that curve is? We can assume here this is an exponential, or not exponential, we can assume it's a quadratic. Why can we assume it's a quadratic? Well, I've got this point -1, 1. I've got the point 0, 0. I've got the point 1, 1, 2, 4. You can imagine if this continued, would have 3, 9, then 4, 16, then 5, 25. So it looks pretty quadratic. This is going to be x squared. Okay. And then this last line right here, the thing that stays consistent on that line is the y value. Y value stays consistently at 3. Okay, next guy. All right, equation for this one. Remember this form, y equals a, x minus h plus k. Now, we know it opens up like a v, so a is positive. And so what's the slope? Let's pick that point and that point. And as I go from this point to this point, I'm going up 1, 2, 3, and I'm going over 1. So the slope is 3 over 1, slope is 3. And my vertex here, that point is -3, 3. So we're going to do x minus -3 plus 3. So we get 3x plus 3 plus 3. And just by coincidence, there's lots of 3's in that equation there. Okay, one more time how we did this. First of all, the slope. The slope is 3, up 3 over 1. And now, because this quadratic has been shifted, so here's an original absolute value function, right? Looks like that. This one's been shifted to the left by 3, and so that's a plus 3. It's been raised up 3, so that's where that comes from. And now it's a lot steeper, and so that's where that 3 comes from. Okay, intervals of increase, decrease, really similar to one we did before. Let's just do this fast. Increase. Increasing from -2.5 to 1. Decreasing -infinity to -2.5. Union 1 to infinity. Okay, another equation, getting kind of repetitive right now. Because it opens like a V, slope is going to be negative. So negative, and then from here to here, looks like we're going down 3 over 1. So like that. Now we're going to do x minus -1 plus 3. So your final answer here looks like this. Okay, here we got to sketch this graph. So x minus 2 minus 2. Because there is an invisible 1 there and it's positive, you know it'll open up like that. Your vertex here, flip that sign 2. This one comes down -2. Let's go and graph that. So x is 2, -2. We've got that point. Slope is just a normal 1, so it looks like that. And we're done. So we've shifted. This one right here is, this is absolute value of x, right? And what we've done is we've shifted it to the right by 2, and so that's where that x minus 2 comes from. The -2 on the inside means we moved it to the right by 2. So this vertex moved to the right by 2, and it also went down by 2. That's what that -2 does. And the slope stayed the same. Slope is still that invisible 1 there. Okay, zeros of this function. Zeros are just these values. 0, 0, 4. X-intercepts are these, but in coordinate pairs, 0, 0, 4, 0. Y-intercept is the same here as the x-intercept because they both go through the origin 0, 0. Okay, more function stuff. Okay, these ones are getting a little bit repetitive here, but let's just do this fast. F of 2 is 1. If f of x is 7, so I'm looking in this f of x column, f of x is 7, then a 5 will make that. Okay, f of -1. So now we're going back this way. F -1 of 1 is going to be 2. And if the output here is a 5, what makes that 5? Well, a 7 would make that. F negative 1 of 7 is equal to 5. If we put 7 into our inverse function, we'll produce that 5. Okay, that's everything.